Two events are independent if the outcome of one event does not affect the probabilities of the outcomes of another. Let's now consider an example of such events. Let X and Y model the outcome of two different persons in two different cities to get home for dinner on time. Since these people live so far from each other and have no effect on each other, we can treat them as independent events. These kinds of events have a property that their joint probability is equal to the product of their individual probabilities. For instance, the joint probability of X and Y is the same as the product of probabilities for X and Y. We can denote such independent events with an uptack. Let's now examine the conditional independence. We will use the same example as before to illustrate the conditional independence. But now, we have a third event Z, which models the probability of there being snow in both cities. The assumption is that snow will make it difficult for them to get home in time for dinner, in turn having an effect on probability. However, these conditional probabilities will still be independent. Hence, for conditionally independent events, joint conditional probability equals the product of their individual conditional probabilities. Essentially, conditional independence is very similar to the previously discussed independence, except we have a certain condition.